Hi, this is Sadman Binzaman. This is EL6303, assignment 4, question number 2. The first part of the question asks us to draw y equals g of x when g of x is defined as being 1 for the interval x being less than 0, g of x equals 0 for the interval 0 less than or equal to x less than 1, equals negative x for 1 less than or equal to x less than or equal to 2, and negative 2 for x being greater than 2. Let's start off by drawing our axes and defining our interval. This will be our y, this will be our x. Our function spans from, on the x-axis, from less than equal to 0 to all the way up to 2. So let's go with negative 1, negative 2, 1, 2. And same thing here. Okay, so for any x that's less than 0, we're going to get it equal to 1. For the interval 0 less than or equal to x less than 1, we get 0. Just connect them. For the interval 1 less than or equal to x less than or equal to 2, we emulate the graph of negative x. So we're only going to get negative x from this span right here. And then afterwards just sustains at negative 2. That is the graph of g of x. The second part of the question asks us to find and draw capital F of y and lowercase f of y in terms of capital F of x and lowercase f of x. And for our reference, they give us the sketch of small f of x, and it looks something like that. When sketching little f of y, we need to be aware of where our impulses lie. Looking at the graph of g of x, we know that the interval negative 2 to 0 generates an impulse at 1 when y equals 1. Similarly, the interval from 0 to 1 will generate an interval where we'll generate impulse at y equals 0. This interval from 1 to 2, it generates a function. There will be no impulse there. From 2 on, we have an impulse again at negative 2. We can go about calculating our impulses by the impulse at y equals negative 2. The probability of y equals negative 2 is equal to the probability of x being greater or equal to 2, which equals to 1 minus the probability of x being less than or equal to 2, which equals 1 minus big F of x of 2. The impulse at y equals 0 is the probability of y equals 0, which equals the probability of 0 less than or equal to x less than or equal to 1, which equals big F of x of 1 minus big F of x of 0. And finally, the impulse at y equals 1 is the probability of y equals 1, which equals the probability of x being less than or equal to 0, which equals big F of x of 0. We can now start graphing our little sketch of little f of y. Let's start off by graphing the impulses. We know that we have an impulses at 3 separate places: y equals negative 2, y equals 0, and y equals 1. So at negative 2, we have an impulse, and we could define that as 1 minus big F of x of 2. We have another impulse at y equals 0. Remember, the horizontal axis here is our y. At y equals 0, we have another impulse. And we can define that as big F of x of 1 minus big f of x of 0. And then we finally have another impulse at y equals 1. And that one we can define as f of x of 0. Now we have to take care of our interval. We look back at g of x, our interval from x equals 1 to 2, which relates to y equals -1 to -2. To map that on our sketch of f of y, we need to take into account the fundamental theorem. And the fundamental theorem tells us that little f of y equals little f of x divided by the derivative, the absolute value of the derivative of g of x, which in our case equals 1. We can look back at the sketch that they gave us of f of x. We know that from the interval 1 to 2, we have this little shape right here. But since on our f of y, we're trying to map it to between -2 and -1, we're going to have the mirror image, or we have to take into account the negative y. So our sketch will look something like this. And that is our f small of y, small f of y. Sorry, I realized that was out of frame. Again, we know that from the sketch they gave us of small f of x, we know that from the interval of 1 to 2, we get a shape of like a small incline. But since for our interval from -2 to -1, we're going to ask for the mirror image, so we're going to sketch it upwards. And that is our sketch of small f of y. To sketch big F of y, we can just integrate our graph of small f of y. Again, since it's not on the same page, let's do a quick sketch. We have an impulse at -2, we have an impulse at 0, and we have an impulse at 1. So let's write out our intervals. So we'll have -2, -1, 1, 2. We know that from the interval we have an impulse at -2. So from -2 to -1, we'll have some area. And that area is going to sustain, meaning there is going to be no addition to it until we reach 0, where the impulse tells us there's going to be a spike. And again, it's going to sustain until it hits +1. And then there's going to be one more spike, and that's going to sustain through. So we can call this 1 minus f of x of 0. That's going to be fx1 minus fx0. And that is fx0. I mean, hopefully that's clear and you guys are able to understand that. Thank you.